Everyone, good evening.
Hi, sir. Good evening.
Hi, sir.
Yes. Hello.
Yes,
So just one request. Can you once again repeat that encoder part? I think I'm a bit confused with that encoder like concept wise. I'm a bit confused. Basically, code was clear completely.
encoder. Okay, no problem. I'll explain.
Yeah.
All right, so see, let's say we have a table here. Okay, just making one table. Let's say there is a variable there, my friend. Let's say I'm saying here Mumbai. Okay, this is location table. Here we have Delhi. Here we have Bangalore. And here we have Chennai. And let's say Gujarat. Okay, now when you say encoder part, we have three steps there. One is called label encoder. Second is called one hot encoder. And the third one is called dummy variable. Now, whenever you do one hot encoder, dummy variable is mandatory. Okay. Label encoder you can do when you have only two unique value there. 2 or 1. You can say 1 or 2. When we have only 1 or 2 unique value there. What is meaning of 1 or 2? Let's say we have a gender given. Now, if we have a male and female given, guys, male, female, right? Male, female is given. Now, can I say only 2 unique value there? Male or female, male or female? Yes or no?
Yes,
So in this case, you have to do a label encoder. And as per alphabetic order, can I say F will come first? So F will consider 0, and wherever 1 there, that will consider 1. Are you with me?
So if we have 4, 5 value, we cannot do the label encoder.
What I said, label encoder you can do when we have only 2 value, then only you can do it. Okay, now if we have a multiple values there, then we have to split the data. Then one hot encoder is mandatory. Okay, now first part, what is the first rule is label encoder you can do if only 1 or 2 variable there, 2 unique value there, not variable, 2 unique value there, then one hot encoder is not required. Encoder is not required. Now, in case I am doing label encoder, right? Now, let's say here in this case, can I say more than 2 unique value there? Can I say here we have a 5 unique value? Everyone? Now, in this case, what you have to do, my dear friend, if you do label encoder, then what happened? As per alphabetic order, it get convert. Encoder, why we are doing? We wanted to char to number. We are changing char to number. That is why we are doing this part. So what you have to do, as per alphabetic order, B will come first. So this is considered 0. C will come second, 1. Then D will come 2. Then G is 3. And then 4. This is the label encoder is. Are you with me, guys? What is label encoder will do? Now,
Yes.
why I'm saying if you have a more than 2 there, then don't do label encoder, because you have to do additional step. Again, you have to split into different column. So if you do this part, then you have to do one hot encoder. Then you have to do one hot encoder. And each value, unique value, you have to segregate into different column. So how many unique value there? 0, 1, 2, 3, 4, 5 columns. So you can say 1, 2, 3, 4, and 5. You have to make 5 columns. This is called one hot encoder. Now, 5 column in the sense, my dear friend, you can just check all the 0, 1, 2, 3, 4, you have to write the variable name. So how you will write it? You can say location 0, location 1, location 2, location 3, and location 4. Are you guys with me, my dear friend? Now here in the location 0, can I say here 0 is there? So that will consider 1, rest everything will consider 0. So what is the rule number 2? If you do one hot encoder means we are transferring, right? Unique value, the numeric value transfer into column. And what value you are placing there? Unique value, binary value. You can say we are giving binary value 0 and 1. So here you can say 1 and rest 0. Here location 1 there. 1 where is there? This one. Location 1. So this is 1, rest everything will consider 0. Here location 2, this is 1, rest everything consider 0. Here location 3, where is location 3? This one, you can say 1, rest everything is 0. And finally, location 4 is here. So you can say this is 1 and rest everything is 0. Are you guys with me or not, my friend? Tell me, what is one hot encoder? So this data, once you do label encoder, when you do one hot encoder, this get removed. You have to remove it now, and you have created a new variable. Now, again, the third part is called dummy variable. I told you if you do one hot encoder, it's a mandatory to dummy variable. Here, not mandatory. If only 2 value there, then no need to convert into column, because by default you are getting 0, 1 only. If we have only 2 value, we are getting 0 and 1, binary value only. So there is no need to create a different column. But if we have more than 2 unique value there, first you can do label encoder and then you can do one hot encoder, or directly you can go and use the one hot encoder. So that will also convert this number accordingly. It gets split and same result you will get it. So that's why suggestion is, if you have more than 2 there, then don't do this activity, just skip this. But that doesn't mean you can't. You can. Amit, clear?
Yes, sir. But what we studied is that always use the label encoder. We should not use one hot encoder or the dummy variable. That's what we studied in our ML model.
I don't know what you have learned, but I'm just telling you this part is you have to follow. Okay, I'm not discussing what you have learned and all, and then that will go in a different direction. Just understand label encoder means we are just converting number to character. Now, if you don't convert into binary value, when you build an algorithm, this data get influenced. When we have a bigger number, your algorithm, your maths get changed. So every time it's ideal, it's a good idea, you can go by the binary value so that it will not impact. And dummy variable means, my friend, dummy variable, whenever you say dummy variable, that means n-1, means how many total column we have created, and means total number of columns we have created, and there you can drop 1. So when you apply the dummy variable, you can say, okay, dummy variable, then please go, and any one data you have to stop it. You can cross this, and only you have to play with this data set only. That is called dummy variable. Now here everywhere 0, 0 is coming. Your system automatically understand it's neither 2, 3, 4, neither 1, 2, 3, 4. Then definitely it's a 0, which we drop it. Okay, so that is what dummy variable there. So whenever you do one hot encoder, dummy variable is mandatory. Please remember this. Now, if you say one hot encoder is not required, so which context it said, that you have to understand. Maybe there are some variables there where we don't need to do it. If we have thousands of unique value there, thousands of unique value there. In this case, it's not a good idea that you can create thousands of variables. So it depends on case to case. All right, but this is what the basic thing for encoding. Are you clear, my friend, who asked me this question?
Yes, sir. Just one more question with this. So we haven't imported the one hot encoder, or we did it?
We did. No, there is a functions there in
Okay.
Python, pd dot get dummies.
Okay.
Get dummies. So what it will do, it automatically convert into column. And also I have written, drop first. In code I have written drop first equal to true. Means dummy variable also there. Both part I did it yesterday, if you remember.
Sir,
So automatically it get removed.
sir, why are we removing this dummy variable?
Because my friend, in machine learning, in first topic algorithm, you have learned linear regression. And there is a topic there, there is assumptions there, right? Assumptions there that there should not be any multi-collinearity. Multi-collinearity. And to remove this one part, you will not get, we can choose here, right? Unnecessary data I'm not giving it. So the reason is multi-collinearity. All right, now don't ask me what is multi-collinearity. Then I will go variance inflation factor, then again all these things. So it will go deviated the topic then.
Sir, I have a
Okay, so
doubt.
please learn the multi-collinearity as well. If you don't know why dummy variable, then you have to understand multi-collinearity, what is multi-collinear, what is the significant, and that part you have to know. Yes, madam, quickly ask me.
Yeah, we have some columns like PCV, WC, where the values are actually integers, but they're in the form of string, that is objects. So shouldn't we be converting them into integers instead of one hot encoding them?
Of course you can do it. If you are aware that that is number only, it's not character, so you can just go and convert that into number. You can say to pd.to underscore numeric and change that value.
Yeah, because WC has, I think, like 25 or 30 unique values. So one hot encoding them will create much more columns, unnecessary columns, right? We can directly convert them into integers.
Good observation. Very good. Agree. What else, my friend? Anybody?
One question, sir. So when we should go for like simple imputation for the missing values and KNN imputation? What is the
When we
difference?
go,
Like
there is
simple,
no difference.
have...
See, these both are techniques actually. There is no specific difference there. What happens sometimes when you build a model, no, your accuracy, you are not, why we are doing it. Ultimate, what is your objective? What is your destination? My model perform better. That is the intention. My accuracy would be higher. So sometime I have seen if you use KNN imputer and all, it will increase 1% better accuracy.
Okay.
If you have a more complex data and then you can go and use it. So these are the methods there. Now you can ask me, when I can solve regression problem by linear regression, what is the purpose to use random forest? What is the purpose for XGBoost regressor? What is your answer? That model will improve more accuracy. That model will give more, less error part. Yes or no?
Yes, yes.
That is why we are using in deep learning also. Why we are using CNN model against deep neural network? Because CNN is known for image processing. Deep learning also do it, but deep learning there are there are discrepancies there. That is creating more, parameters. So that's why we prefer to go by this.
And one more thing, sir. What should be the limit? Like how much percentage value? If we see like 40% missing values in a data set, should we remove that column or should we impute them?
25% industry is considering 25% is the threshold value. If you are getting more than 25%, please drop it. But even I'm saying if you are getting 10% missing data, still you can take consent from your stakeholder. Drop a mail take their confirmation, and then you have to do it. Because in case in real time, if they ask why you did it, who has given the permission and all. So that time you can't say basis my experience and all. You have to explain them. Yes or no?
Yes, yes.
So that thing you have to be careful.
Okay.
So yeah, I have one more doubt with the encoder. Suppose if we have thousands of category in that particular feature, then what we'll do?
I told you, no, it depends on the case study. You will not decide here. When you see the data set, if thousands of variable there, that variable is a significant or non-significant. If that is significant, then you have to do it. Now, if you are just doing level encoder, is there impact on my algorithm? If yes, then you have to do it one hot encoder. You can convert the data into 0 and 1. Hardly matter for me whether it's 1,000 or what. When we are using machine learning, when we are using automation, no worry at all. Right? Machine will do, sklearn will do all these things. You are not doing manually. So you can go freely and you can do it and then apply PCA method and all data get removed. That is the approach you have to follow. Understood?
Yeah.
Yeah, but again, it depends what type of case study is this, what variable that is, where you are getting thousands of variable. Maybe that variable is a name, maybe address, non-significant for me, drop it. But you can say location, I'm doing COVID data set, and location is a significant variable. We are not supposed to drop location. We are not supposed to drop city, because I wanted to predict city by city, how much positive cases there. So on that case, what you do I need to convert into one hot encoder? No, not required. Are you with me? You can do a EDA part, you can analyze it. But when you build a model algorithm, that time definitely if you don't change into 0 to 1,000, it will impact, no, because that is number.
Yes. Yes.
Machine always think number, right? They are not thinking about this. So that's why we are converting it to binary value and then we are predicting it. So it depends what type of problem you are doing it. If you are doing just analysis purpose, EDA purpose, don't do that. Just convert and then you have to analyze it. But you are building a machine learning. And again, it depends. So you have to, you cannot, made up your mind and you cannot paint with the same brush that, okay, well, I did the same activities in another case study. Can I do here also? No, not like that. It changes. It depends on case to case, my friend. Clear? So every time you should be, aware that what I have to do, you can understand. If you need clarity, you can check with, anybody is there who is a SME of that project. They have a domain knowledge. Check with them what variable it is. Do I really need to change it? Otherwise, if you do level encoder, let's say ID there, employee ID there. Is it significant variable for me? Not at all. If you do a level encoder, what happened? Unnecessary, it will go thousands of thousands column or not. Drop that variable. Okay, no problem. So shall we start now, my friend?
Yes, sir.
Otherwise, I think so project session will become classroom session. So let me go here and GPU is already there. Connect. Let me upload the data set, kidney data set. Okay. So now, my friend, just a recap session. So we have what we did yesterday. We have taken a basic package, we imported here. Then we imported the data set. After that, we just wanted to check what is the information given in the data set. So it's a real-time data, my friend. One thing you can notice, there are lots of object there. And this is what my friend has highlighted just now, that if these are the number, then what is the purpose? Why we are considering? Why not this object we can convert into number or float value? Okay, so appreciated to ask this question. So you have to just build this. You can see, do we have missing data? Yes, there are missing data, but these missing data is more than 25%. But I'm not dropping it. Why? Because my dear friend, this RBC is really required to identify whether patient has a kidney disease or kidney problem or not. Right? So these are the variable is a significant parameter. Now I'm just, what I'm doing, wherever the missing data there, I'm just going by this approach. I told you, you have to treat separately. If time requires, no worry, you can go and just treat one by one. Don't go the shortcut trick, and sometimes, you know, it create a problem. So you have to change it. I'm just going by this because it will not impact much. And, you know, otherwise I have to spend lots of time. Now here you can see this part, I'm getting all null value. Then I told you, when you do this part, my friend, when you check this variable, then what happened? There are lots of, you know, zero values, null value there. There are lots of unwanted data there. So what you do, you can see these are the variables. So for that, we have used NP-ware techniques and some other techniques as well. So you have to change it, change it. I'm just telling you method, my friend. You have to be careful about this. So this is done, now done, and done. Okay, so this is, we did it. Now you can see here what happened. Everything is showing as an object only. Because whenever you do these activities, no, whenever you know, I have done this part, my friend. You can say simple imputer, I did it. Whenever you do simple imputer, that by default get converted into object part. That is the by default function there in sklearn. So you know what I have to do? I have to convert back to the actual form. So here I'm saying for I in data frame select data type exclude object. So, right, so whatever object there, you can put object remain as it is, but rest whatever there, please convert into number. So you have to do it, and now you can check the same data and how we have a data earlier. You can see exactly I'm getting the same way. So here I'm getting the same way. Now these are the target things. These are the part I have to see whether this is really number or the really object or it's a number. Okay. So what we have to do here, you can just say data frame imputed dot head and see this. So RBC, yes, it's a character. PC is a character. PCC is character. BA is character, right? Next part, it's not visible. So if you want, you can write the function call to see all the value, right? Or else you can open the data set also. Or you can just set pd.set and increase the width, length and all. But I'm just opening this Excel sheet. And let me see what is this. Okay, so this is, these four are object, very good. Rest here. HTN is also character, right? These all are character only. So in between anything is character there. BGR to RC, BGDR to RC, BGR, PVC is coming. This is correct, right? BA and PCB, so this PCB, HTN, hemoglobin, PCB, hemoglobin, PCB. Okay, this is character is showing. PCB to RC is a character. PCB to RCN, right? These three are actually number, but system is saying character, right, my friend?
Yes,
Yeah. So what you do here, just let me write it this. You can say data frame, what is name there? Data frame imputed, and here you can say PCV equal to, you have to write here PD dot 2 underscore numeric. Okay, and just pass here the same data set. Next, copy this complete line and paste here and paste here. And what is second? WC. So write here WC and WC. And here next is RC. Execute this. What happened? Saying unable to parse a string. So some missing data there. What happened?
In RC, we have one data so that we have not handled, I think.
Oh, RC we have not take care.
Question mark and T was there, something. One value.
So that is why it's showing error. Let me see, no problem. PCB. RC. So here this value is still coming, right? So can I copy this RC? RC. And what is coming? Equal to, not this one I have to apply. So RC, and here it's coming question mark, same, right? This one. So can I put it here? If this is coming, then what is the median value for this? Or mode value? Because right now it's object, so I'm just going by most frequent 5.2. Can I put here 5.2? And execute this. Okay, now it's fine. Let me try this one. Let me try this one. It's correct. Now, my friend, let me see again. Info. So this is perfectly fine, right? All three get converted. Now just give me a glance again. The data set is the object is coming here, which is RBC2 BA. So RBC2 BA, this is correct. Then object is coming. This value is HTN2 classification. HTN2 classification. Is it okay now, my dear friend? Classification is my dependent variable, so we'll segregate this. So this part is clear, my friend, everyone. Now I have taken the, which is number, that is fine.
Yes.
Yeah. Now you have to just do some box plot. See where this value is there and some distribution plot. Now the main thing is we have to split the data here. So you can say data classification, we have this value. Here I'm saying split the data into X and Y. And X is coming this and Y is coming this. So this is the X and all value except these one are my object and these are the objects. So here you can go and directly you can convert this. So can I say PCB, WC and RC is not required? Yes or no?
Yes.
All right. So now you have to remove this. You can say only this part I need it, RBC, this BA, HTN, this APN, and drop equal to first. So this is my friend, one hot encoder and dummy variable. Execute this. Done. This part is done. And what is the shape now? What is the shape now? 25 column only. See? So that means that is not a problem at all. Yesterday I got somewhere, I think 196, right, my friend?
Yes.
Yeah, because I have taken number also. Nobody have noticed this one. So that is the problem. Yeah, so you have to see that part also, my friend. All my friend, you are with me till now? Comfortable?
Yes.
Yeah. So now I have splitted the data, and also I have not too much variable there, 25 only. So I'm fine with this. Okay, so no need to do, other activities, but still if you wanted to do some PCA part or LDA part, right? Definitely if you have a more 196, then I would suggest you can go and do this. Here you can just build a model, but still if you feel that the improvement is not there in my model and all, I will try to do the feature selection part as well, right? But right now what I'm doing here, can I say feature scaling of feature scaling is required or not, guys? To see the value here 48, here 121, 423, 135, and other as 1.1 and something like that. Can I do a feature scaling?
Yes.
Yes.
Yeah. So please go and do here. You can say feature scaling. Feature scaling. So what we have to do, have you seen outlier also there, right? When I use the box plot, my friend, when I use the box plot, can I say lots of outlier there? You can see there are lots of outlier there. Yes or no? So if there is an outlier, what approach you will go? I taught you in last.
Standard scalar.
So you can say from sklearn dot pre-processing import standard scalar, and scalar equal to, you have to say standard scalar. Next, x, you can say x scalar equal to scalar dot fit underscore transform, and here my friend you can say x, and that's it. Okay, so this is what I have scaled the data, and now I have y also. Now what we have to do, my friend, can I split the data into training and test?
Yes.
Yeah. If you wanted to do PCA and LDA method, my friend, I'm just writing for your information, but I'm changing. I will not apply that one, okay? Because I have 25 column only. That it suffice. We can easily go and use the machine learning techniques. So just for your information, I'm just doing here PCA method for understanding only. Okay, so you can see how many PCA will say that we have a non-significant variable here. If I ask you x dot shape, I'm getting here, my friend, there are 25 variables there. And if I'm applying PCA method, my friend, you can see this part. Let me put on top. Okay, you can see here, my friend, I'm using PCA method. So what happened, you can say from sklearn dot decomposition import PCA, principal component analysis. Now PCA is a very good techniques, my friend, for dimension reduction, but only challenge is you will not get a visibility, right? Which variable we have to consider and which variable not, because the maths is it's such a way so that it will give always the eigenvalue, and they are giving the expected value, which is the how much information they are giving it. So here simply I'm writing PCA equal to, you can say PCA parenthesis bracket and 0.95. So you can say if I'm getting 95% information, please take that variable, and rest anything is there, please remove it. Okay, now simply you can write here, you can say x underscore PCA. Okay, I'm creating a new variable which I will not use, right? I will use this one, x scalar, I will use it. So I'm just writing here x PCA, and this part I'm applying here, you can say PCA dot fit underscore transform, and here I'm passing x. Now you can see, my dear friend, print what is my original shape there, x dot shape 25. Now print what is my, after doing PCA, what value I'm getting it. Execute this. Sorry, we have to put here dot shape. My friend, what happened?
One column only.
Only one column I'm getting it. Have you noticed? Maybe I have run twice, that's why it's coming one. Ideally it should not. Let me run again, because I did twice, no? Run all, restart and run all. Just wait. Because I run twice, no? That is the problem. PC is a brilliant idea. That doesn't mean kidney disease is depend on only one variable, no? Why it's showing error? Something has happened. Could not convert the flat T. Okay. So T I have not convert. Somewhere is coming something. Okay. We'll do later. Now see here, if I'm doing this, again, it's only one surprising. Wow. So it removed 25 variables, which is very bad, no?
Because we have taken 95% valid data, if we reduce it, maybe we can take more.
Yeah, if I'm saying this, let's say I'm putting here 90% information, then how many is coming? One only. Very weird, no? No, it's not a good option. Let me try the linear discriminant analysis. See what happened in linear discriminant, because they're saying only one significant variable out of this there. So see, one thing, please remember, you can go PCA when you have a huge variable, right? So many variables there, then you have to go. Let me try this part, no? From scalon dot discriminate analysis import linear discrete analysis, all right, as LDA. Execute this, and now I'm seeing LDA equal to LDA. Okay, and then you can say X LDA dot fit underscore transform, and here I'm passing X. Now you can say print X dot shape and print X dot X LDA dot shape. What happened? Saying fit missing one required positional argument Y. Okay, so in LDA we have to write Y also. No problem. So here also I'm getting one, guys. So it's a very weird why this is coming. So this value they are not giving any significant for 0 and 1, and out of this whatever coming, ID is of course non-significant for me. A is VP, and this part they are calculating and considering it. The only one variable is the significant one. No, this is not the good idea, guys. Okay, I'm not going by this PCA method. So this is just a code I have written, my friend. Please don't use, because one variable then no meaning, right? There is no make sense to do this. PCA, I'm really surprised. Let me do some remove part. If I remove ID, can I say X equal to guys, if you are not speaking, please go on mute, right? Otherwise others get disturbed, and I'm also disturbing. So my friend, I'm saying X equal to, can I drop this part, my friend? X dot drop. Please tell me, can I drop this ID first? ID is non-significant for me or not?
Yes, sir.
Yes, we can.
Yeah. And
Yes.
what else? What else? Just see any parameter other than this. Age and all, I have no visibility, right? You can say I have no visibility. So only ID part, I'm dropping it. Okay. You can say access equal to 1. Now this is what is there. Now, if I say x dot head, this is what I'm getting it. Okay, now perfect, 24 column. Now let me run it because maybe ID is there. That's why PCA is doing this, blunder. Let me change this because this is not acceptable. PCA, how it's giving 1? LDA is okay because
Sir, should we take a scaled data?
not required, but ID is there. That's why. Just wait. No, see what happened now. Why this is coming? Wait. Put as a comment. Again, same is coming up. PCA is 1 only, even though I have removed this. And what happened if I put a scaled data then? Scale is anyway, it's array format. We have to convert this, but let me try. So 20 now, maybe a scale is there. That's why it's coming. So now guys, you can see here, my PCA is saying 20 variable I have to take. Okay, and here also, if I'm taking a scaled, so LDA is 1. Okay, I understood why LDA is coming because that is what LDA is. And that's why people not prefer to go by LDA, but PCA is okay, right? They have just removed only 4 variable, which was non-significant. And we need 20 variable with which we can solve the problem. But right now I'm not taking it, just I did it, guys. Okay. I'm not doing this part. I'm not doing this LDA at all. So just for reference. Just for reference. Full maths there, guys. Anybody don't know what is linear discriminant analysis and what is PCA and what is TSNA? Then maybe we'll take some session and we'll discuss all the dimension techniques, feature engineering techniques, and we'll explain you the mathematics part. Yeah.
Okay.
Because I really need, this part is very, very significant part. You have to know feature engineering techniques. So full maths there. If you guys have learned, very good. If not, then please go and learn it. Also, if in my batch, if any class is there, you can must join or you can watch video. Okay, that is what you can do. Here, my friend, I'm not using PCA. I'm just going by the simple scalar data. So what you have to do, you can say from scalon dot model selection import train test split, and then you can say x train, x test, y train, y test equal to train test split, and you have to write x-axis. X-axis is what? My x scalar, right? That is my x-axis. Y is my y only dependent variable. Test size equal to, let's say I'm writing 0.2, and then random state equal to, I'm writing 1. Any number you have to give. Okay. Pallavi is asking, sir, can you show which is the 1 column output by PCA? Pallavi, in PCA, I told you several times, PCA, you will not get any visibility about which variable is this. This is the theory is there, right? So if you learn, if you have gone through the PCA topic, you will understand. PCA will not give you a visibility that which column, is this. All right. Okay, my friend. So this is done. I have splitted the data into train and test. Now what we have to do, you can just go and build the model. Okay. So can I build all model, my friend, at one go? Everyone?
Yes, please.
Yeah, so I'm just going and building all model at one go. So here you can say from sklearn dot matrix import confusion matrix classification report and accuracy and F1 score. In fact, everything you will get there only. For precision, not required. Why I'm doing this? Classification report will give you all. Yeah, so I'm just removing it. From sklearn, the best model I'm using ensemble technique first. Ensemble import. I'm saying voting classifier. All right. Then you can say from sklearn dot linear model import logistic regression. Then from sklearn dot tree import decision tree classifier. Next from sklearn dot ensemble import random forest classifier.
The first column comma voting classifier comma random.
Sorry.
After ensemble import voting classifier, when put a comma and put the random classifier, right? Random forest.
We can write it. I'm just writing separately, no problem. You can write there also, no problem. From sklearn dot support vector machine import support vector machine classifier support vector classifier. From sklearn dot neighbors import k nearest neighbor classifier. Next from sklearn dot neighbors import Gaussian neighbors from sklearn dot neighbors import Bernoulli's neighbors. What else? That's it, right? If you want anything else, you can add it, but I think it's okay. Now I'm saying list of metrics. You can say list of, just let me run this. Yeah, this is working fine. My friend, now you can say, if you want, you can add ADA boost, gradient boosting, XGBoost, right? All these things you can add it, my friend. No problem at all. So this is suffice. I'll do it voting classification, and I will append all the algorithm at one go. And you can see, then you have to decide which is the best model. So here I'm saying list matrix equal to blank. I don't know. You can say list accuracy equal to blank. And then you have to apply all the algorithm, one by one, my friend. So what you do first, I'm saying classification classifier equal to, let's say I'm picking logistic regression. And rather I can say classifier, I'm saying logit. Some makes sense. Logit equal to this logistic regression. And then my friend, LR equal to, you can say logit dot fit. And you have to pass here X train, Y train, Y train, and then Y predict LR equal to logit dot predict parenthesis bracket X test. Now you can say here accuracy LR equal to accuracy score, and here you can say Y test comma Y predict. Are you guys with me, my dear friend? This part, what I did here, I have built the logistic regression, right?
Isn't
And
it
then,
wiped LR?
yeah, I have used the logistic regression, my dear friend, and then I have applied the logistic regression fit X train and X test, and then I have predicted this, and also I have calculated the accuracy parameter. Okay, same thing, my friend. Please copy this. Here I'm saying this is my logistic regression. Logistic regression. Please copy this, paste here. My job is very simple. I'm just saying here decision tree. Decision tree. And here you can say DT. And please go and copy this decision tree.
It should be LR dot predict, no, in IPRED, Y underscore pred underscore LR.
Oh, that is no Y data. Why predict this?
No, your logit dot predict, instead of that, it should be LR dot predict, right? Or
here
LR dot predict, no?
Oh, no problem. Here I have given this, no.
Okay, so it's right. Correct.
So a created model is logit only.
Yeah, it's going to be.
Okay, now DT, here you can say DT decision tree. Or if you have confusion, write logit only. Is it okay? No, it's fine.
Yeah, okay.
No problem. That will not create a problem at all. DT. And here you can say DT. All right, everything is done, my friend. Here, can I write DT? Rest, everything is fine? Yes, no?
Yeah.
Okay. Now, next part, again, please copy this. Paste here. Next model is random forest. Say random forest. Random forest. RF. I'm going basic model, my friend. I'm not changing anything. Not writing any parameter right now. Just I'm showing you how you can do this by manual approach.
Can we write a function for this?
Sorry?
Can we write a function?
Can I write a function?
Yeah.
That also will do, but I'm creating object. If you write function, then will not happen. No. So I'm creating first object, and then I will use inner voting. And all model I will pass it. Okay. So next part is, my friend, copy this, paste here, and say next part is called support vector classifier. Support vector classifier. Support vector classifier. Support vector classifier. SVC. 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 Done. Next is k nearest neighbor classifier. Almost done. Say k neighbor classifier, knn, knn. And the second last part is let's say I'm not writing this one, only I'm doing Gaussian Bayes. Bayes theorem, NB. All right, so this is done. Now what we have to do here, my friend, the last part, we are using the voting techniques. So I'm saying combining all the above model with voting classifier, or stacking also you can do. I'll show you a stacking as well. Now you can say evaluation classifier equal to, copy this voting classifier, parenthesis bracket, and here my friend you can say whatever the estimators there, you can say equal to, you have to write all name. So what is the name I have given? One logit. So you can say logit is denoted by logit. Okay, this is my one class. Close this parenthesis bracket. Next is comma. What is next? Decision tree dt. Copy this. You can say decision tree known as dt. Next is RF, random forest. You can say RF. Next is SVC, support vector classifier. What is next?
V.
KNN, right? KNN. And the last one is like that, my friend. You can spend some time and write all at one go. Paste. And then finally you can say voting equal to now you can say model evaluation classifier equal to evaluation classifier fit and pass here X train comma Y train. Predict evaluation classifier dot predict. You have to pass here X test. Okay, and the last is accuracy evaluation classifier equal to accuracy score. You can say Y test comma Y predict evaluation classifier. All right. So this is what happened, my friend. I did it all part at one go. Now what we have to do here, you can say list one equal to, just write here. The first I have used logistic regression. Second model I have used decision tree. Third model I have used random forest. Next I have used support vector classifier or support vector machine. Next k nearest neighbors, then neighbors theorem. All right, this is my list one. Now you can say list two equal to, you have to just write all one by one. Go this accuracy LR, comma, accuracy decision tree, accuracy random forest, accuracy, what is there after random forest? Support vector classifier, then accuracy KNN, and then accuracy, my friend, deep base. Yeah, so this is my list two. Now also you can add the accuracy EVC as well. EVC. All right, and here also I'm adding the EVC as well. So I'm adding the last voting also. Classifier. So this is done. This is my list two. Now I'm saying list three equal to, you can say here, you can just write here logit can I do that list three, or can I go ahead here only? Okay, let me do one thing. Can we do this? Let me write this down. Logit, comma, decision tree, comma, random forest, comma, support vector classifier, then KNN, and then KNN, and then this, and then I have given model. Okay. These are the things, my dear friend, I have given here. Now what we have to do? We're also writing model is. So all this part, list three. Now
how about classification report?
Sorry?
Classification report, do we need?
You can put classification report also, but you have to add everywhere. I have added only accuracy. You can add classifier also, and then you can add that part also. Anything you want, you can do it. Okay. Now, my dear friend, all part done. Now you have to accumulate all the values. You can say data frame accuracy equal to, you can say here pd dot data frame.
It should be like,
sorry,
yeah, it should be like model EVC dot pitran. The
model
variable.
EVC, where I have written model EVC only, no? Did I make some
dot
mistake? Oh, here
yeah,
I have given EVC now. It should be model EVC, right?
Correct.
Thank you. model ABC and model. Correct now?
Correct.
Okay. So data frame, then you can say method used. First is list one. Second is my accuracy, which is list two. And that's it. I have used it. List three I'm not using right now because I have given list one is this and list three. And then you can see here print data frame accuracy, and then you can create chart equal to sns.bar plot, and here you can say x equal to, you can write here method y equal to, you can say accuracy, and then data equal to, you can say data frame accuracy. Copy this. So I have to create a visualization as well. Now you can say chart dot set x ticks labels. Here you can say chart dot get underscore x tick labels parenthesis bracket, and rotation is equal to 90 degrees. Print chart. Okay, so my friend, I have used everything and now I'm running it. Let's hope that no error happened. Let's see. Yeah. So my dear friend, you can see I'm getting here method use, logistic regression, decision tree, random forest, support vector machine, naive-based theorem, okay, nearest neighbor, naive-based theorem, and voting techniques. What is the accuracy for all individual? Random forest is leading, right? And voting also is very good because I have combined all the model and then I have used it, right? And I'm getting this one. Are you guys with me? Now you can pick any data, and what is the next part you have to do, guys? Any model you can say, and this is the visualization also, you can showcase that why you will go which model. Now let's say voting is very good model, right? I'm saying voting is combination of all. What you do, my friend, you can go here the model accuracy where you have given this part. Okay, these two part, please come here and do some analysis with the training and test both. So you can see evaluation train equal to, you have to put here train, and similarly predict evaluation test equal to, you can say model evaluation dot predict, and here you can say x test. Okay, and this is now accuracy score for training and accuracy score for test. You can do it. So train is test is already done. You can say y train, and here you can say predict this train. And then finally, my friend, you can say print accuracy score training and accuracy score test. Copy this, because machine learning, the biggest challenge is underfitting and overfitting problem, right? High bias and high variance problem. I'm sure bias is not there because I'm getting 98.5, but I'm just looking training accuracy as well, so that we'll see whether variance is there or what. Print and this one, and execute here. See this, my friend.
You have to go to predict EVC underscore test, right? Accuracy EVC test.
Accuracy EVC test. Test also I have checked here, and training also I have checked.
After accuracy score, y test, comma, predict EVC underscore test, right?
Here, huh?
Yeah.
Yeah. So I think in the previous one they have taken. Now it's fine. Yeah, so see here, my friend, training is 99.6 and test is 98.5. Can I say no underfitting, no overfitting problem? Model is absolutely fine. Everyone? Yes.
Could you explain in detail the concept here you have applied? I didn't get it.
This one.
Yeah, the entire cell. What did you do here?
Which one? This one or this one? Last one?
Yeah, that one. Last one.
What I did here, see, I have just built the model, right? And now I'm predicting it. So what is the concept there? We have a train and test there, right? When you predict this, when you see the result, if training is coming close to 90% and test is coming 50%, then this problem is called overfitting problem. Overfitting problem. What is meaning of overfitting? High variance. So training is okay. Training is okay, but test when you do, that means there is a overfitting problem, high variance there. So you have to reject the model. It's not good model at all. If training is giving less accuracy, let's say less than 70%, 50%, and test is also giving, because this model is very poor, so test will also give poor, that is called underfitting problem. Underfitting problem. What is meaning of underfitting? Can I say high bias problem? Yes or no? These two challenge there in machine learning.
Yes, sir.
Now in training, I'm getting here 99.6%. I'm just checking the test data, what percentage is coming. So I'm getting 98.75. Now how much variance there? Can I say somewhere is 1% or less than 1%?
Yes.
Any train data and test data, if you get 10% and above, then you can say, yes, there is a high variance there. High variance there. So that is why I have checked with the training accuracy also and test accuracy also. So first, when I build a model, I pass train data. When I build the model, I pass test data as well. And both I have stored in the different object. And when I predict, right, we are finding the accuracy score, I'm getting this one. This part. So can I say I have a confidence now that this is definitely, it's not overfitting or underfitting problem?
But sir, by the time I have implemented this code, the model has already seen the X-train and X-test data, right?
Model has already seen X-train. No, that on the same model I'm doing, no. So model accuracy I have not seen, no. Test accuracy you have seen it, but model, when you train the model, that accuracy, if anybody say, when you build the model, what accuracy you are getting here? How you know that it's a high bias problem? When you check train, how you will check it? So I already built the model here.
Yeah.
When I'm predicting it, I'm passing the same data so that I can see my accuracy, training accuracy, how much is coming.
Okay.
Understood?
Yeah. But my doubt is, by this time the model has already seen how the X-train data is, so it can actually easily predict.
The model has seen. So that is that part. That's why I'm comparing. No, that's why I'm comparing it. So model has seen the data. When you are passing the same data, what accuracy, what model is predicting? So it's a seen data, absolutely right. But when you are passing the same data and you are predicting again, that is giving 99.68, means closer to 100% correct. That means whatever you have built, that is, seen. That's why you are getting this result. No.
Yeah.
And when I'm giving the new data, test data, that is also giving very good. And what is the variance coming between this? Only 1%, less than 1%. So that means I have a confidence that it's, no variance, no bias there. My model is absolutely right.
Yeah. And for the accuracy of the random forest, we have got 100%. So can we say that it has undergone overfitting?
How you can say? First, you have to check the train also. No, that's why I did these activities. 100% means you can't say that the model is underfitting. Underfitting and overfitting problem is this only. You cannot judge with the 100%. You can go here. Again, you can do the same activities. No, copy this, paste here. And what you have to do, you can just write here, random forest, this one, the random forest, right? Copy this. And please paste here. You can say random forest, rain. And accuracy score this random forest. Copy this and this.
Train.
Just okay. And here you can write y train and y predict. Not this one. I think I have taken wrong. Random forest is this one, right? Copy this. This one. Here you can say train, pass here train data. Train data. Now please copy this, paste here again. And you can say test and test. Now evaluation matrix, accuracy score y train. And can I put here y train? Can I put here y test? And this is my random forest. Random forest. Let's see this. Random forest. Execute this. See, both are coming, whatever the data you have given, as it is, training and test, both are coming 100%. Now, why I said 100%, I will not prefer, you can't see overfitting problem, right? Because training also giving. I will trust more on voting, because voting is what? Random forest is also ensemble techniques, right? Can I say it's a bagging method, my friend? What random forest did it? We have a multiple decision tree. No, this is the data set there. Multiple decision tree they have taken. Yes,
yes,
sir.
sir.
And
Yes.
each data frame, how they sample it? Can I say row sampling plus feature sampling with replacement?
Yes.
With replacement, each model, they have built a decision tree 1, decision tree 2, decision tree 3. Yes or no?
Yes.
And so on. Multiple decision tree they have built it. Okay. And then what happened? We have to aggregate all this model. And we get one model, and as per voting, whatever the prediction there, so that is correct, coming correctly. So as per voting, we are saying whatever the result is there. Now you can say why 100 and 100% is coming, because my friend, please understand, 400 only data there, patient details there, and I'm building a random forest. Random forest is a black box method. Yes or no? All data is a decision tree only doing it. And decision tree itself, first model itself is giving 98%. Now, if I build multiple decision tree, I think by default, how many tree is creating? I think 100 decision tree is there, right? 100 or 500, let me see. By default decision tree, how many tree get created, guys? You can see here.
I think it's 100.
Yeah, it's 100, I think. Let me see. It's not coming. Yeah. See here what is coming, my friend. What is this coming? So see how many number of estimated equal to 100. So when we have only 300 data there, because 400 I have taken 20% test data, only 80% data there, 320 data, and one decision tree itself is giving 98%. Then if you make 100 decision tree, will give 100% accuracy or not? Tell me. Does it make sense or not?
Yeah, it does make sense. But in the decision tree, if the default parameters are min sample leaf is equals to 1, and I think max depth is equals to 10, I think.
Decision tree, what this?
We have some default parameters in the decision tree, right?
Correct.
We haven't done any hyperparameter tuning.
I have not
right?
done anything. Yeah, basic model is giving hyperparameter. Why I will go when there is a problem happen, then I will go. No hyperparameter tuning. I have, in fact, I have not changed. Gini to entropy also. By default, I have used it. So there is no problem at all. See, when you do the hyperparameter, when you use grid search or randomized search CB, when my accuracy, I can see more variance is there, right? Some accuracy difference is there, then I will go and use it. Here, not required.
Yeah. I asked that out because we have only 25 columns and the default max depth is 10. So I think there would be a chance of overfitting, and the final leaf nodes will be, the sample size will be
So
1.
you can use, so that part also you can check it. See, right now I have just built the basic model. Here I did it and I found this is the good one. Now let's say random forest is the best one. Here, if you go and just apply the grid search CB, can I do that part now? Can I use the hyperparameter tuning?
Sure.
Everybody?
Yes. Why do we need it? In fact, we are getting a good accuracy.
I'm getting it, but just for information. Can I write the hyperparameter tuning also so that you will get some visibility?
Yes.
Yeah. So I'm just using hyperparameter tuning. Hyperparameter tuning. Here not required, but in case when you do some, other project, you may need. So you can do it. You can say grid search CB. Grid search CB. So what happened? You can say from sklearn dot model selection, and I'm using import grid search CB. Execute this. This is fine. Now you can say tuned parameter.
Sir, sorry to disturb, but before like hyperparameter tuning, should we not find that recall value? Because since it's a healthcare domain, and then we will try to just
no, very good observation. So let's say I'm going here this recall parameter, right? What you do, copy this line, and just write it. What is the big deal? My friend, you have asked very good question. Copy this, paste here, and just do classification report. And here, that's it. Execute here. Accuracy, it's not accuracy, you can say classification. Copy and paste here. Is it okay, my friend? This is what you are looking. Execute this, you will get a precision, recall, F1 score, everything you will get it. See? Are you with me?
Yeah.
This is what you are looking. See? Perfectly fine, 100%, because data is very less, no?
Yeah.
When you have a very less data, what you will do? Right? And we have done all pre-processing very carefully, thoroughly, and all this thing. So ensemble learning definitely will give you a better result. Even you can see KNN also giving good result. No, you can say K nearest neighbor is giving, even though it's a distance matrix, 92%. Naive-Bayes theorem is a probability theorem. It's giving 95%. Voting is, of course, you can say it's an ensemble method, and we combined all the method. Then I'm getting 98.75. But these two also, you can say it's a distance matrix. This is my probability matrix, right? Bayes theorem only. And Bayes theorem is giving a brilliant result. Because we have a very less data. See, my purpose is not I can pick, 50 lakh data and my system get hanged here. I wanted to understand how you will do it. At one go, you can do it, all this thing. If model is not working fine, you can use the grid search. You can use other parameter also. Clear?
Yeah, thank you.
Now, my friend, can I do hyperparameter tuning? Everybody? You can, if you want, you can use ROC and AOC curve also. That will also give you a visibility, right? I'm just using tune parameter here, my friend. And what are the things there? Let me write here random forest first. Random random forest classifier parenthesis bracket. And let me see this. What is the things coming? So here number of estimator is coming. Criteria is coming, right? Then maximum depth is there. Minimum sample. Let's say a few things I'm taking. Number of estimator I'm taking here. Copy and paste here. Can I say number of estimator equal to, my friend? Can I write here? Can I write here some number? I'm saying here 7, 8, 9, 10, 11, 12, 13, 14. Okay, let's say I'm just writing it, or some random number you can give, not necessarily in the sequence order. You can say 7, 9, 12, 15, 16, 20, like that. You have to give some number, guys. Yes or no? So I'm giving, let's say 1, 2, 3, 4, 5, 6, 4 more I'm giving it. Let's say 17, 18, 25, and 30. Okay, this is the number of estimated I have given. Next part, my friend. Next part. Criteria, maximum depth. Let's say I'm taking maximum depth. So you can write here, comma, max depth equal to, let's say here also I'm writing some number, 2, 3, 4, 5. Okay, and let's say none. I don't know what is this. Now, what else? Here it will not impact much, my friend, to be very honest, because just I'm writing a pattern so that you know it will not impact
Entropy or
much.
Gini.
Entropy and Gini also I can give it. That is 2. Now, minimum sample split is okay.
Min sample leaf.
Sample leaf, minimum weight fraction is also okay. This minimum leaf observations, this form class weight I'm giving, it's coming none. Let me write, I'm giving some weight value here. If you guys have learned deep learning, my friend, weight has a big role there, right? So class weight, let's say I'm saying here, you can assign some weight also. I'm saying here none, of course none. Then I'm giving some value apart from that, 0 to 0.33, 1 to 0.67. Okay, like that I'm giving it. Okay. Next part, what we have to do. Next, what we have to do. This. And let me say balanced. Okay. And you have to write here random state equal to some number. I'm giving it random state equal to, let's say I'm saying 42. All right. Now that now you can say classification equal to pick the grid search, and then you have to write a parenthesis bracket, and you have to just pass here random forest classifier, and here, my friend, I'm giving criteria equal to, my friend, by default criteria, what is coming by default? Can I say Gini will come?
Yes.
Yeah, so I'm just changing the criteria. By default is already there. Now I'm changing here criteria equal to, see, by default system will consider this. I'm saying entropy. So criteria equal to entropy. entropy. All right. Now, then I will pass it the tune parameter, whatever I have given apart from this tune parameter. And here cross validation also I'm applying here, my friend, 10. I hope everybody know k-fold method, cross validation.
Yes, sir.
Yeah, so I'm using cross validation also. And then you can see here. It's not coming. So estimator grid search scoring equal to this, number of this, and dictionary functions role. Okay, that's it. I'm just giving that part only, cross validation 10, and that's it. All right. Now please go here and just do this. You can say classification dot fit, and you have to pass here now X train, comma Y train, and then say print detailed classification report equal to, you can say Y true LR predict, or simply I'm writing here. Can I say, or it's okay, Y true, and just let's say LR predict equal to, you can say Y test, comma classification dot predict. You have to pass here X test. Yeah. Now you can say print classification report equal to Y true, comma LR predict. Copy this line. Again, you can say print, give some space, and then print. Here I'm writing right, my dear friend. And then if you want more, just first try this.
So what does this parameter class weight signify?
Which one?
Class weight parameter.
That is, we are just assigning some weight value. So when you know one variable, how significant that variable is impacting to our dependent variable. So normally what happened, you know, you have seen this y equal to mx plus c. So let's say I'm saying multi-class c plus m1 x1 plus m2 x2, okay, plus m3 x3. So this is my independent variable, and these are my slope there. Yes. Slope is nothing, it's a weight actually. So your independent variable decided the weight, right? How much, if weight is very high, then can I say x is slightly improved, then y get improved? No, it gets changed.
Yeah, if weight is high, right?
Right. Yeah. So that is what the weight I have given, class weight. Each variable, the weight is some weight I have given 33%, and they are 67%. So 100% weight there. I've just categorized into two parameters. So machine will pick and they will decide that what is the best and all. Okay. See, have you learned deep learning?
No.
Oh, then okay. then weight, no problem. Deep learning, we will discuss weight in very detail, but here in machine learning also you have learned, no? What is the formula there in max, this one, logistic regression? Can I say weight equal to argument max, and we have to put the weight value, and then we are saying actual value minus predicted value, their square.
Okay.
Yeah, and you have learned this part, ln p by 1 minus p equal to beta naught plus beta 1 x1 plus beta 2 x2 plus up to so on plus epsilon value. Did you remember? This is called odds, log odds. That's why the name suggests logit. What is this beta 1, beta 2, beta 3? This is nothing. It's a weight only,
Slope.
no? Slope or coefficient or weight.
Yeah.
Okay, so guys, when we use the parameter grid search, you can see I'm getting here checked. Patient is that much accuracy, precision recall, not check that one. If you go overall, I'm getting that one, and 98.7% accuracy I'm getting it. Very good or not? After doing 10 times, will you trust more in this data or not? Tell me. After doing 10 iteration, my friend, here cross validation, I have changed 10 times and then I'm getting 98.7%. Very good or not? Tell me.
Yeah, it's good.
Yeah, so this is the approach, my dear friend, you have to do when you build a model. I can do many more things here, my friend, in this data set. I can build NLP also. If I have a more data there, sorry, I'm saying NLP, or deep neural network also. I can use some other method also. There are so many methods there, right? I can apply that one also. But my suggestion is, like that, you have to perform it. So main part is pre-processing EDA and all. Once you know, then you have to write all model at one go. I have in fact written only few model. I would suggest you can spend some time. You can just write ADA boost, gradient boosting, XGBoost, right? All model in support vector machine. I have given only RBF. No, here you can see support vector. I have given blank. Blank means what? Can I say RBF there only? You can see if I put blank means RBF only. Yes or no? Here you can see kernel size equal to, you will get RBF only. Kernel equal to RBF. But actually we have a kernel equal to polynomial also, linear also, sigmoid also, right? So all part you have to patiently write it. And where I use voting, you can use a stacking also. I hope you guys have learned a stacking as well. That is there in ML extent. Yes or no?
No, I think.
No.
Yes.
So there is a, so other project when I pick, maybe I will teach you the stacking method. Here, the way I said voting here, I will trust more on voting, guys, because you can see what I did here. What I did here when I use the voting classifier, I have used all model at one go. See, everything I have used it. And then I predicted it. So similarly, you can use a stacking. These two model you will use very frequently in industry when you get a job. Means then you have justification that I tried all model, and after that even ensemble, and then I appended it, and then I created a new model. And after that, this model done, please go and apply the grid search. Grid search or randomized search. Randomized search you can go when you have a huge data. Grid search you can go when you have less data, right? Because grid search is looking all one by one, line by line. If I use randomized search, they will not check all value. Randomly, they will pick some value and give the answer. So that part you can do. And now you can see I have done the cross validation also. And that is what I'm getting the answer. How brilliant answer I'm getting. And I'm ready to, you can say, ask, give me the data set, give me these detail. I will tell you whether patient has a kidney problem or not, or whether it will happen or not. Machine will ready to do it. And that is what you can, feed in the robo or something. No, if you know reinforcement learning, you can apply that part also in the machine. They can take decision. First, you can train all this thing, and at a certain level of time, they will decide. I hope, my friend, some makes sense.
Yes, sir.
Yeah. So lots of things, my friend, I have not done here. Like EDA part, I didn't do that. I would request you can go and do the EDA part also. Right? At least you can do Panda profiling so that you will get a visibility also how the data looks like, what is this and all. Just 2-3 lines. Please go and write the Panda profiling and you can get the better result. Yes, no, my dear friend?
Yes, sir.
Yes, sir.
We can do that.
So can I share this code with you all?
Yes.
Yes.
So let me save this. And
any of the future projects will we use binning techniques?
Binning techniques you need, then maybe I will pick some data set and I'll show you how you can split it. See,
Yes,
binning
sir.
is basically is what have you seen tightening data set?
Yes.
Yeah, so there you can use binning. What happened here, you will get ticket number. So some number is coming. Basically, you will get the data like that. A100, A100, right? You will get something. So by the help of binning, you can split the data. So I'll pick some data set. I'll show you the binning concept then.
Yeah.
So you will be teaching the web scraping as well?
Web scraping already completed, no? I already taught them. But in this batch, I don't know. I think this is second class only for this batch. Yes, I will cover again.
Which one?
Okay, so I will come. That is web scraping is asking. So web scraping I covered in last batch for COVID data set. I did it. I went on Worldometer website and fetch all the data in my system, and then I did forecasting. So I'll do it. Okay. Future project, maybe I'll pick some time series forecasting, then I'll do the web scraping and I'll show you how we can do it. Okay, sir.
So is this the last class for the healthcare domain?
This is the second class only for this batch. See, one project I have completed marketing, and this is the second project for healthcare. Next week, I'll pick another project.
Okay.
Maybe share your LMS driving also.
Okay.
So marketing project is done.
Marketing done yesterday, last week only.
Okay.
You were not there in last week.
Yeah, the message actually was shared by Learnbay, I think 5 days before only, to join the project classes.
Yeah, last week only I have covered marketing.
Yesterday only, for our batch.
Okay, so you got to know yesterday. So healthcare completed, don't worry, you can continue. This batch is going on, it's keep going on. This Saturday, Sunday, every Saturday, Sunday, you will get a class, and every Saturday, Sunday, you will get a different domain. So how this is happening, continuously, I will cover 10 domain project. Once 10 is completed, again we'll reverse back, all 10 domain again repeated. Maybe data set I'm changing it, but the concept, the domain is remain same.
Sir.
Okay. So let's say healthcare is completed now. That doesn't mean healthcare will not come. 10 class after 10 week, you will get again healthcare, but with the different data set. If you are lucky, then you will get a millions of data. If you're lucky, then you will get something, but it's keep happening. So every project I'm going, class by class, and every time data will change, but concept, the project, domain is remains same. Marketing, healthcare, HR domain, telecom domain, a supply chain domain, right? Banking and finance domain. So these domain will keep going on.
Sir, are we planning to take any healthcare domain project with the cancer images or any type of images instead of taking CSV data?
I'll see why I have not taken that one, because most of the friend, they have not learned deep learning, right? So that is the problem there. So if I pick the scanned image and all, I have to go by the CNN model, right? I have to go by computer vision. Now there you guys get stuck. So if you guys are confident, you said, yeah, I have learned deep learning, I know CNN method, I know computer vision concept, right? Then I'm more than happy to go that project, right? But if not, then you have to trust in class only. When you learn in class, there only I'll teach you that part. Because here we are going with the population, no? Here different batches there. Some of the friend, they have learned machine learning only. Some of the friend, they are learning machine learning. It's not completed also. So if I go in direct image part, and if I start using the CNN methods and all, transfer learning and all, everything will just put their hand, No, what is this? What is the purpose for this batch and all that? They will not understand. So for you, if you are interested that part, then of course you can join my batch where I'm taking advanced AI and deep learning classes. You will learn that topics.
So which batch?
Which batch? It's a weekend batch, weekdays batch, so many batches there. Ask with Simran, no? You can ask, check with her that which batch I'm taking in advanced AI.
Okay, so thank you.
Yeah. There are some completed batch also there. You can go and watch video also. You can leverage, you can learn this thing. I have already covered there.
Okay.
All right, so that's it for today, my friend. Anybody? Yeah, yes, quickly.
Yeah, sir, for this data set, can we use deep learning? Because we'll get a poor accuracy, right, for a small data set.
So if a small data set there, don't go by deep learning. No. Deep learning is the data hungry. So how you will go by 400 data set? That's why I've not used.
Okay.
What madam asked, she asked me about the image processing, cancer image detection and all. If anybody has cancer, then how you will understand? You need their, you have to see that, right? So then we will go in deep learning and all. Deep learning also I'll go in, but here in the majority people, they have not learned deep learning. If you guys are comfortable, I'm more than happy. Deep learning, we have an amazing project there. We have a music generation project there. I can, I will teach you in class and how system generate the music. You will really surprise. You need not to go and take class from A.R. Rahman and all. If you know deep learning, you can generate your own music, right? You can do, anything. You have seen lots of things happen, invention after 2012, no? Self-drive car is another, amazing project. Uber or Ola, right? How they are predicting when you book a cab, how you are getting, how much time it takes, what amount you have to pay, which is the shortest distance there. Everything you can do it. But for that, you tell me, you have a confidence. You can say, I know deep neural networks, CNN, RNN, LSTM, and GRU, and along with NLP. I'm okay. I'll pick this. But for that, whatever I'm saying that you will not learn, you will learn in class. Here, this batch is not for this, for that project and all. This batch is basically a mix of machine learning and deep learning. Not too advanced, not too, this. And whatever the industry is looking, we will discuss that part mainly. Okay. So let's just see what happened, what project will come in the next session. Maybe some project will come for deep learning related. So you will learn there. Okay, I'm picking 10 projects. Maybe I will extend 2-3 more projects, and that is completely deep learning. And I'll teach you that part also. Okay, so you can continue your class wherever you are learning. Side by side, you can join weekend batch also and learn this. Okay, guys. So that's it for today. Thank you very much, my friend.